In this lesson video, we're going to be taking a look at congruent triangles. Congruent triangles are triangles with the same size and shape. And this means that all corresponding parts are congruent. That means all corresponding sides are congruent and all corresponding angles are congruent. So when we have congruent triangles, we can make what is called a congruency statement. When triangles are congruent, we can write a congruency statement, and that congruency statement helps us understand which parts match up to each other. So in this, I've got triangle ABC, and it's congruent to triangle DEF. Now, when I say that congruency statement, when I make this congruency statement here, I'm stating not only that the triangles altogether are congruent, but their individual parts that match up are also congruent. By saying the letters in this order, I'm saying that angle A and angle D have to be the congruent angles to each other. And angle B and angle E have to be congruent to each other. And angle C and angle F have to be congruent angles to each other. And so you'll see those marked here. A is congruent to D. B is congruent to E. And C is congruent to F. Not only that, but corresponding sides that match up according to this label are also congruent. Okay? So a valid congruency statement must match all corresponding angles and sides in the right order. And because of that, we have this other mathematical idea based on the definition of congruent triangles, and that is the phrase CPCTC. And here's what that stands for. Corresponding parts of congruent triangles are congruent. C for corresponding, P for parts, C congruent, T for triangles, C for congruent again. CPCTC. If we know that two triangles are congruent, then we know that every pair of corresponding parts is also congruent. So what we can do is we can use these congruency statements to identify those corresponding congruent parts. So we're told that triangle JKL is congruent to triangle PQR. From that, I know all the pairs of matching corresponding congruent pieces. For example, I know that angle J must be congruent to its corresponding angle P. And I know angle K has to be congruent to angle Q, and angle L has to be congruent to angle R. But not only that, I know that corresponding sides would have to be congruent. So the first side I should recognize for triangle JKL is segment JK. That must match up to segment PQ, so they must be congruent. So I can say segment JK is congruent to segment PQ. The next two together would be KL is congruent to QR. And then finally, JL has to be congruent to PR. So we've identified all three pairs of congruent angles and all three pairs of congruent sides. So if I change the order of the letters for one triangle, I have to change the order of the letters for the other one to show that they still match up. So another valid congruency statement might be triangle KLJ. That would have to be congruent to triangle QRP, so that I still have these matching up in correct corresponding parts. Sorry, I forgot my triangle symbol. Let me add that back in. Okay? So what we can do is we can use the congruency statement to help find missing pieces or to help identify corresponding parts. So in this next example, we're going to use this statement really more than we're even going to use the picture to identify corresponding parts. You should see that KM is congruent to AC. CY would be congruent to MP. PK would have to be congruent to YA. Angle Y would have to be congruent to angle P. Angle K is congruent to angle A. And then angle ACY, A, C, then Y, has to be congruent to K, M, then P. Then triangle, PKM, these last two are congruency statements themselves. Triangle, MPK, would have to be congruent to triangle, CYA. And then part H, triangle YAC, would have to be congruent to triangle PKM. And it's just matching. That's all we're doing. We're matching the order of the letters in the right order. And then we could mark the picture to go along with that, but we don't have to. So let's go to the next page. What we have based on that then is these triangle congruent theorems. Now, to show that triangles are congruent or to prove that triangles are congruent, a lot of the times we would have to show that all three angles of one triangle are congruent to all three angles of another, and all three sides of one triangle are congruent to their corresponding sides in the other. However, because of a concept called triangle rigidity, we can actually take some shortcuts. And the first shortcut is this: side, side, side. If three sides of one triangle are congruent to three sides of another, the triangles have to be congruent. So I might mark this side congruent to this side, this one congruent to this one, and then the bottom sides of each one's congruent as well. Those triangles have to be congruent by side, side, side. Another one is called side, angle, side. If two sides of one triangle and the included angle, meaning the angle between those two sides, so two sides of one triangle and the angle between those sides is congruent to two sides of another triangle and the angle between those sides, the triangles have to be congruent. So we'd call that side, angle, side. And if you're going kind of around the triangle in order, we go from a side to an angle, then a side. Well, we also have one called angle, side, angle. Angle, side, angle is where we have two angles of one triangle and the side that's included between the angles. Included means between. So those are congruent to two angles of another triangle and the side included between those. So angle, side, angle. Similarly, if two angles of a triangle and a side that's not included, one of the sides opposite those angles, are congruent to two angles of another triangle and its matching side opposite one of the angles, then angle, angle, side would be used to say they are congruent. And then finally, we have one other arrangement of ideas that help me prove triangles are congruent, and that's the idea of hypotenuse leg. If the hypotenuse and any one leg of a right triangle are congruent to the hypotenuse and any one leg of another right triangle, the triangles have to be congruent. So like the hypotenuse congruent to the hypotenuse, and one leg here congruent to its matching leg here. That means these triangles would have to be congruent. This only works in right triangles. Hypotenuse leg only works in right triangles because right triangles are the only triangles in which we have a hypotenuse. Okay, so one of the things you're going to have to do is be given a picture, and you want to state if these two triangles can be congruent or not. Basically, will one of those 5 reasons apply? If yes, give me whichever reason it is. If not, then just say no. But you need to understand there's more information here than just what you see marked. We do have right angles marked. I've got right triangles then. So in order for a hypotenuse leg to work, the hypotenuses need to be congruent and one pair of matching legs. Well, I have the marked sides here and here, the matching legs. But another thing you need to recognize is that these two triangles have a common side. A common or shared side. That side has to be the same length as itself. So both triangles use that side as their hypotenuse, so the hypotenuses have to be congruent. So we can mark a common or shared side congruent to itself with a single tick mark. That means these triangles are congruent by HL. Okay? Part B, again, we have a common or shared side here. That side's congruent to itself. But I don't have right triangles here, but I do have a pair of angles marked congruent there, and another pair of sides marked congruent there. So I have angles, and then sides, and then sides. Now, angle, side is not one of the ones I had at the top. And in fact, if you tried to write the shortened version of that, pretty soon you would realize that's not something we should write down. Not just because of what that would spell, but because it's not actually going to apply. That's not a valid congruency statement. So these are not congruent. Okay, part C here, we have two triangles with marked sides congruent, marked angles congruent, but again, there's more than meets the eye here. We have vertical angles which have to be congruent if you remember back to some of our previous lessons. So those vertical angles are also congruent, so I want to mark those. Well, that would mean these triangles are congruent by angle, side, angle. Because the vertical angles are congruent as well. So you need to get in the habit of looking for these extra things to write down. Anytime you have vertical angles, like on part D, we can mark those as congruent. Well, that makes these triangles congruent by angle, angle, side. Because the side markings are not drawn between the angle markings. Now, if I was trying to do something like this with part E, the only thing I have there is 3 angles congruent to 3 angles. Well, we don't have anything called angle, 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 so these would not necessarily be congruent. Then for part F, we should recognize those are congruent by side, angle, side. Okay? To finish this up, on the next page, this time I've given you a similar picture to what we were using on the previous page, but I've also given you one of those congruence reasons, side, 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 angle, side, etc. And I want you to state what additional information we would need to use this. Well, I've got my congruent sides marked here and here, and I have the common sides, TV and VT. The additional information I would need to use for side, side, side would be these sides congruent, which would mean UT needs to be congruent to TL. That's the additional information needed. The shared or common side isn't additional information. It's there. We just have to mark it. Okay, part B, kind of the same idea here. We do have something that is there that we just need to mark, and that's the vertical angles. But the common side, or there's no common side, I'm sorry. The vertical angles just give me the angles that are congruent. In order to use angle, angle, side, I need another pair of angles that would be opposite the two sides that are marked congruent. Well, that would be angle V and angle I. I need angle V to be congruent to angle I in order to use angle side. Okay. Part C, in order to use angle side angle, I need the angle on the other side of the congruent side marking to be congruent. So I need angle C to be congruent to angle X. And then finally for D, in order to use hypotenuse leg, all you see there is the right angle marking, but that means they're both right triangles. We do have a common or shared side, GH to GH. That would be the legs of both triangles. I just need the hypotenuses. So I need HM to be congruent to HI. Hopefully this helps you understand this lesson. You should be ready to do the assignment now.